Good evening, ladies and gentlemen. I welcome you all to Shito's mathematics coaching program. Before the commencement of today's lecture, so I urge every one of you to kindly subscribe to my YouTube channel, hit on the bell right at the subscribe button so you can get my video anytime I drop them. At least you get the notification. So we will be discussing today what we meant by Argand plane and polar representation of complex number. So there's not how you do something on complex number without being introduced to what we mean by Argand plane and polar representation of complex number. So now Argand plane, that is a plane, we call it Argand plane or we call it complex plane at times. So it's a plane, that is a plane where you can have complex number assigned to each of its points. So that is what we call complex or Argand plane. So this type of thing, actually it looks like what? It looks like a Cartesian plane. Cartesian plane is just a plane where a real number is assigned to each of its points. But here, so now instead of we saying real number, so we'll be saying complex number. So that's the difference between the two. So Cartesian plane and complex or Argand plane. So we call it complex or Argand plane. So now another thing is the same way we represent our points on Cartesian plane, so it's the same thing we do on Argand plane. Any point found on this plane is represented by x, y. So the same thing happened to this Argand plane. So we still represent our point like this. It's just that the x is taking the value from real number, that is from real parts, while y is taking the value from imaginary part. So now from here, when we have Cartesian plane, so we have real axis and you can see that the y and the x axis they are real. But here now our y axis is called imaginary axis here. Y x axis is called real axis. So that is the difference. So x is coming from the real axis x, while y is coming from the y axis, that is imaginary axis. So now let's say we now have this point here. So we have this point here. Understand? Say we have this place is our origin, that is where these x are starting from, that is they are starting from 0, 0, that is the origin. So let's say we now have a line drawn from here to this P. Understand? So we call this one R, that is the distance from the origin to these points we have on this plane is what is called R, and at the same time we call this one modulus. If you don't forget, you know that we've already mentioned what we mean by modulus. So we call this modulus, that is a distance from the origin to P. So that is what we call modulus or magnitude or argument. So from here you can see that this is starting from the center O. You understand? From the center O. So now you can see that if you try to introduce this one, to extend this one from here, you can see that from here to here this is x. From here to here this is y. Are you getting it now? So now from here we can actually get the formula for our modulus, that is R here. And don't forget that from this center, so we have an angle here, that is theta. You can see. So you try to measure this theta from this axis, that is OX, anti-clockwise. You understand? So this theta here is called we call this argument here, because they can ask you to find your argument. We call the theta argument or amplitude. Anyone you call it amplitude. So which this theta is also represented as that is our argument. So we represent it or we write it as what? Arg z like this. You understand? So arg means what? Arg on z. That is the theta. That is this theta here. Are you getting it now? So now from here we can have what? We can have our formula for modulus by Pythagoras or by Pythagoras theorem. So by Pythagoras theorem, that is by Pythagoras theorem, you can see that our r, that is r square, is same thing as the what? As the sum, that is square plus what? Plus y square. Can you see that? That is, this is the opposite and this is the adjacent. So we have our r to be equals to the square root of what? S squared plus what? Plus y squared. I don't know, are you following? Now, so now from here our r is equal to this. Therefore, r is same thing as square root of S squared plus what? Plus y squared. Are you getting it now? So that is what we call our what? Our modulus from here. So now, if you now want to go to what, because we have modulus r and what, and polar, we now say polar representation of complex number. Understand? So when we are now talking about polar, so we want to divert from seeing x and y. Understand? Then we'll be saying r and theta. That is, we want to be saying the modulus and what, and what is it called? We want to be saying the modulus and what, and the argument. That is our argument. So that's what we'll be saying now. So now from there, so what is the next thing to do? The next thing to do is to, let's say we have also, you can have, let's say you want to look for the sine theta here. To get sine theta, you know that you have this formula, that is a formula that is so catua. You can say sine, so catua. So catua is same thing as opposite hypotenuse. What is our opposite here? Our opposite here is y. The hypotenuse here is r. Automatically, we have our y. When you try to cross multiply, we have our y to be r sine what? Sine theta. Then cos theta will be equals to, from here, adjacent hypotenuse. What is our adjacent here? Our adjacent is x, then hypotenuse is what? Is r. So automatically we have x to be what? R cos what? Cos theta. Are you getting it now? So now, if at all you want to get this tan, theta, the formula you are going to use is what? Tan theta will be opposite over adjacent. What is the opposite? Y over what? Over adjacent, that is x. So from there, taking the tan inverse of this, we have tan to be what? Or theta to be tan inverse y over x. So that is the formula. If at all you are asked to get your modulus, so this is the formula we are going to use. Then we have this equation. Let's say we have this equation. So now, taking this, now if they ask you to get the argument, this is the formula, this is what you have. You have your tan will be what? Your theta will be tan inverse of y over x. So now, giving z to be equal to s plus iy, you can see that is this complex number. This is the form of complex number where s is what is real part and y is what imaginary part. Don't be confused. Actually, I've been using a and b to denote my real and y to denote my imaginary. But here, I just decided to use x and y because we are dealing with what? We are dealing with Argand plane. You know, if you are talking about Argand plane, so we'll be talking about what? We'll be talking about axis. So, and I told you that from Argand plane, so we still decide to use what? We also decide to use x I mean x axis and y axis. Y-x is real and y-axis is what is imaginary axis. So that is why I decided to use x and y. So it's not what nothing wrong with that. So now I can call this one equation. Let me say equation star star. This one is star, equation star star. So now from here you will be given a kind of problem in form of x and y that is like this. So now they will now ask you to transform that particular z to polar form. So now to see or to have polar form, so there's something you'll be seeing. Our variable will now change entirely from x and y to r and theta, that is the modulus and argument. So therefore, if you are given any form of that to do, so what do? You look for your r, and same time this is the formula for r, and you use what? You use this formula for tan or your theta, your argument, then you input it. Now from here, so we can have z to be equals to, don't be confused that your s here is what is actually a. Your s in polar form is what is represented by this. So we have r cos theta plus I. Here we have what? We have our y here to be what? To be r sin theta, r sin theta. So now from here you can see that there is what? There is a term, as in there is a particular factor that is common. We have r is common. We have cos theta plus what? Plus I sin theta. So all this equation star star star. So that is what? That is form of what? That is polar form. This is how you represent what? You represent a complex number in what? In polar form. So now, giving this example in order to buttress our points, to buttress what we've been saying since morning. So if you are given a question to solve or to express in what? In polar form, so how do you do? So now let's look at this one. Example 1 or example, express z to be equals to 4.3i, understand, in polar form. To express this in polar form, so how do you do? So now you don't need to stop yourself, but something is very, very important. Always what? Always bring out your Argand plane. So let's say I have the rough one here. So you can see that my s is, the 4 is coming from my what? From x. So this is s, this is y. So let's say I have 4 here, and this, let's say I have 3 here. Can you see that? So now this is the point. Understand? This is where your z is. So you have 4,3. If you try to trace this, you trace this one like this. So we have our origin here. So a line from here to this point here is called our r, and we need it. And from here to here is called our theta, so we need that too. I get it. So from here to here is 4, and from here to here is 3. So from there you can actually get your r. You can actually get your r from there, because you have the formula s squared plus what? Plus y squared. So our r is equal to, what is s squared? The x, that is 4 squared, plus what is y squared is what? Is y squared is 3 squared. Yeah, so it's 3 squared. So what will now be the formula, and what will now be the actual value? The actual value will be root of 25. This is equal to what? This is equal to 5, because 4 squared is 16, then 3 squared is what? Is 9. So 16 plus 9, you have what? You have root 25, and root 25 is what? Is 5. Therefore our r here is what? Is 5. So now the next thing to do is to get your argument. So how do you get your arguments? So this is the formula here. So we try to apply the formula. So applying the formula, we have what? We have theta to be tan inverse of what? Tan inverse of y over x. And from the given problem, y is same thing as what? Y is same thing as 3, and what? And x is same thing as 4. So we have this. So if you try to press your calculator, So now tan inverse of 3 over 4, which actually gives us what we have. What we have theta to be 36.86. So now this is 36.86 in degree. So now if we want to put your answer in form of what? In form of you want to put your answer in form of degree DMS system. So that is degree, from degree to minutes to seconds. Therefore, what you are going to do is that, or this will be 36 degree plus 0.86 times 60. So that will give you your minutes. Are you getting it? So now 36 plus the 0.86 is what is the fractional part, that is the decimal part of this. Multiplied by 60 will give you your minutes. So therefore we have our theta to be 36 degree. We have our theta to be what? To be 36 degree 52 what? 52 minutes. So that is what we call the theta. So now you've already gotten your r to be 5 and your theta to be this. So what's the next thing to do? The next thing to do is just to plug them. Okay, you plug them into a form of what? Of representing z, as in our form of polar form. I don't know. Are you getting what I'm saying now? So now, therefore, your z will be equals to r is what? Is 5 into brackets cos what? What is our theta? That is 36 degree 52 plus I, then sine 36 degree 52 minutes. So now that is what? That is that. So now if you like, you can try to write this in, you can try to write this one in what is it called? You can try to write it in form like this, that is in this form where you have real and imaginary parts. What we do is just to take this, use this 5 to multiply or to open the brackets or to expand this bracket, so you have what? You have your real part and imaginary part separately. So now that is how it is done. So now from here, so at times using this one, this is very, 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 if you are talking about polar representation, so it is very good, and you must leave your argument, that is your theta. Okay, you leave your theta, your arguments in what? In degree form. Understand? But if you are asked or you are required to write your angle in radian, so that is when we can do that. I get what I'm saying. That is when you can do that. So that is how we can. And at the same time, there's another way of writing this. That is, you can write it in form of what? In form of exponential form. That is, it will be in exponential form. So maybe that will be in our next video. So we try to look at how we can represent a complex number that is in what? In polar form, in what? In also in exponential form. So that is where we are going to stop today. So if at all you, from what we've done so far, there is something or there is one way or the other that maybe you don't understand anything or you are confused about what we have done, so don't not hesitate. That is, do not hesitate to ask any questions. Try to hit on the comment box and ask any question of your choice. So, and I promise I will give you the best answer to your question. So I remain my humble self, Shitu. And also, if you have not clicked on that subscribe, so please do that and hit the bell right at the same point of that subscribe button, so you can get the notifications of my videos anytime I drop them. So you have a wonderful and a nice day. Thanks.